Hello everyone, this is Chris Jaiswal, one of the core members of the OS Club, and welcome to Grunfeld Project. Starting from this video, we'll be studying about the backend architectures and the basics of system design that you will be needing once you start creating your own backend applications in different other languages using frameworks. So in this video, we'll be starting to know about what is a client server architecture, what happens when you type something on the search engine, how exactly is it resolved, and how exactly HTTPS works. So for this video, we'll keep it till HTTPS working, specified by the TLS 1.2 specification for HTTPS. TLS 1.3 will be covering in some other videos. So let's begin with this one. So when we talk about a client server architecture, it's important for us to understand what a client is and what a server is before actually understanding about its architecture. A client can be anything that is available over the internet. Maybe you can say your cellular phones. Maybe you can say it could be your laptops that are connected over the internet. Maybe you can say it can be your personal computers, tablets, etc. So anything, any physical entity that is available over a network, over the internet, that is a client. Now, let's say that I have Mr. Ramlal. I'm sorry for the handwriting. So let's say I have Mr. Ramlal. Mr. Ramlal wants to know that how exactly he should water the plants. So let's say he has a rice plantation and he wants to know that how exactly will he grow that crop. For that, he goes to his Google search engine, and there he types how to water or how to sow the seeds for a rice plantation. Now what happens here is the mobile phone that Ramlal uses to search this query is called a client. This client sends the request containing the query that Ramlal had on how to sow the seeds for a rice plantation to the server, that is in this case the google.com. And then after receiving the query, the server processes something within itself and then returns the response to Mr. Ramlal in the form of paginated results. Now this exactly is the client server architecture. There is a client that sends a request to the server, and the server, after processing the request, receives or like sends a response to the back to the client. But the main thing being, is it this simple that the client sends a request and then server gives the client a response and then it is rendered using the front end present the client side? No, it's definitely not that simple. Within this client server architecture, what happens is there are a set of rules called network protocols, which both the request and response follow. So sending a request would also need a set of predefined rules or protocols that should be followed in order to send a request successfully. And then receiving a response from the server also requires a set of rules or protocols that the server should follow when it is sending a response. In short, the data transmission that is happening, it follows a set of rules that is called the network protocols. But let us now understand in the depth what is there in the depths of typing or searching something on a web browser and how it happens. So this is kind of like a case study on what would happen if you query something, if you search for something on a client browser. So let's say here we have a client browser. It could be any browser of your choice: Chrome, Brave, Microsoft Edge, whatever. You are a client. Say, let's just suppose that with an example, Mr. Ramlal was a client. Okay, he searched for what exactly or how exactly he would sow the seeds for a rice plantation. So what happened was, in the client browser, there was something like this. This URL was created, HTTPS, then a colon, then two slash, then google.com, then again a slash, then search, and then a question mark, q is equals, and then the search, whatever Mr. Ramlal searched for. And then he pressed for the search button. Once he pressed the search button, request directly does not go to the Google server. Why? Because the client browser has the domain name as google.com. And if we send a request to google.com, I mean, that's actually quite unresolvable from the internet's point of view. So, firstly, in order to get the IP address for google.com, our request hits the DNS server. Now, this domain name system keeps a DNS record for all the domain names and their IP addresses. Okay, so let's say if I'm saying google.com, the DNS server would send me the IP address for google.com that may vary place to place. Let's say just for example 198.161.2.3. Now, this IP address is what the network is going to identify as the Google server where this request has to be resolved, where this HTTP request has to be resolved. And since we talked about the network protocols, the protocol, if you can identify here, is the HTTPS. That is Hypertext Transfer Protocol, secure. Now, we'll learn about this in the later part of the video. But firstly, in the dissection of a URL, the first part is the communication protocol, after which the domain name follows. Once the domain name is done, then there is an endpoint, that is search. And after the search, you mention the query parameter, that is, let's say in this example, hello world. And when you click on search, the first thing that the browser does is it goes to the DNS server to get the IP address against google.com, against this particular domain name. Then the DNS server runs some DNS lookup for its records and then returns the IP address. Now, this IP address is the place where the Google server will respond. So, the next step that happens is the HTTP request. Now, this HTTP request is resolved on this IP address, mind you. So, this is the third step. Now, this HTTP request goes to the Google server. And now the Google server processes, like what response I should give for this query. It finds out a lot of, like a bunch of information, bunch of data. And then it returns the most search engine optimized response, paginated search engine optimized response to the client browser. After which, the client browser middleware processes it in the form of a readable response, because here, whatever you get is a raw JSON format, let's say. It is a raw JSON data in the response. And if I just render the raw JSON data, you won't be actually be able to read it. And that is not even readable up to an extent if you're not a developer. So it is the responsibility of the browsers and like the client browser to render this JSON format in a paginated way. And that's how you get like, if you scroll way down after searching something on Google, you would get these options of 1, 2, 3, 4. And all of these are like paginated options. If you click on 2, you would get a separate set of responses rendered on your screen. So this middleware is responsible, kind of like a front end, is responsible for rendering the responses that are received from the server. And that's how Ramlal got to know how to sow the crop seeds, and that's how we actually consume them. But this is in case of HTTP protocols only. Oops. Let me just delete this. Yeah, this is in case of HTTP protocols. What are HTTP protocols? But HTTP protocols are just a set of rules, just like other network protocols, that both a client and server should follow during a client server request response exchange, or like the data transmission. But in reality, HTTPS is used. So what is the difference if I say, HTTP example.com xyz, and if I say https example.com xyz. So this main difference we can understand with the help of this diagram. Let's say you are a client, okay, and you go to your banking application just to uh, do some transactions, okay, to some xyz bank. Now you being a client, you send your ATM card number, your CVV, your expiry to the server. The server here being the XYZ bank, and then the server responds with, the payment is done. But let's say there are some crabs. No, these are no seafood. These crabs are like those attackers, like hackers, black hat hackers, who might be overlooking on this insecure HTTP connection. And what happens is, instead of sending an encrypted data here, the HTTP protocol sends plain text of requests to the server, and server responds with a plain text of things to the client, which clearly means that the connection is not secure. Now, apart from you, this X-Men also have the access to your ATM card number, your CVV, and your bank details, and then you might as well get a OTP very soon, which they'll be able to crack through and retrieve all your bank balance. To prevent this, since this is an HTTP connection, to prevent this, the internet makers decided to have HTTPS. To prevent the X-Men to gain access of your sensitive data, they introduced a vast and robust set of mechanisms to prevent this situation from happening at the first place. And this protocol was termed HTTPS, Hypertext Transfer Protocol Secure, just an upgraded version of HTTP. So, how does HTTPS differ from HTTP and how does it work exactly? Let us learn about that now. So, there is something that is known as the handshake. I mean, let's say there are two users, they meet after a long time. What do? They handshake. It's that simple. In the similar way, there is a TCP handshake between the client and the server before a request is sent. Now, this all process is happening before the request is sent. Okay, so first step is the establishment of a connection between the client and the server, and then comes the certificate verification. Now, what happens in the case of a certificate verification, or what exactly is a certificate? So, for any domain, let's say this domain itself, HTTPS has a certificate to prove that this particular website is secure, and that is it is verified by the signing authorities. So, this certificate verification happens in step 2 after the connection between a client and the server is established. So what happens is, the step 1 is the left clap. Just understanding the handshake theorem, it's a left clap, that is the client hello. Now within this client hello, what I am doing is I'm sending a list of TLS versions, transport layer security. I'll tell about this in detail in some other video. So I'm sending a TLS versions, set of TLS versions, and encryption algos client and the server could mutually work on. That is done in this client hello, kind of like a cipher suit, nothing else. Once that is done, then it is the server's responsibility to agree on a set of encryption algorithms that it can perform out of the list of this TLS and encryption algorithms. Like, one of the algorithms is decided, and the server communicates this to the client side with the help of another server hello, that is the right clap. It is the server's duty to choose the best version of the TLS version and encryption algorithm among this list of sent algorithms in the TLS versions. So the server sends this, this is the encryption algorithm that we are going to use, and then this is the uh, TLS version that we are going to choose, and along with that, it sends a certificate which includes the public key, so that it could verify that who exactly the server is. Now, certificate verification at this point is completed. The third step that comes in is the key exchange. So now that the certificate verification is done, what happens is there is the third step, that is the key exchange. Here, there is a pre-master key that is generated and that is encrypted and sent over to the server. Now, the server uses the public key in order to decode that pre-master key. And now the server says that I will use a private key of my own to decrypt the pre-master key, that is the session key. Once that is done, only then the data transmission, that is the request and the responses, start to happen. Because till this point, till the third step, all of this was happening openly. There were nothing that is secured. So even if the attackers get access to any of these keys, they won't be able to decrypt anything if they don't have the private key that is residing in the server. A better example of understanding this would be, I say that I have a public key and I say that I have a private key. The combination of these two keys will unlock or will be able to decrypt the encrypted data that is being sent over from the client side and to encrypt the data that we are sending as a response from the server to the client side. This thing in all happens with two types of encryption, that is the asymmetric encryption that it happens initially in the step 1 in the TCP handshake, after which the connection is established, and then the symmetric encryption where these two keys are used in order to encrypt and decrypt the session data. This is exactly how TLS 1.2 specification of HTTPS works. That's it for this video. If you have any other questions, you can hit the comment section. I'll also send a Google form so that you can ask your questions there itself. Thank you for watching.